Okay, everybody, so what we're going to be doing today is we're going to be looking at exponents. We're going to start with the first part, which is the basic exponent rules. Most of this should be a review from pre-algebra, but we want to make sure you really understand it before we start using them and moving on. First thing, we're going to talk about the forms. So exponential form means written out in the form with an exponent. There are two parts to an exponential form. First, you have this number right here, which is known as your base, and the number on the right side, which is known as the exponent. This right now is written out in exponential form. So if I ask you to take something that's long multiplication and write it in exponential form, this is what I mean. This can be said a couple different ways. One could be 5 raised to the 6th power. Another could be just simply 5 to the 6th power. Okay, next up, we're going to look at expanded form. All that means is literally like written out the long way, expanded. Okay, when you start something close together and it gets bigger, it's expanding. So here's an example, 5 to the 2nd power. What I'm going to do is I'm going to write it out. 5 times 5, which of course is 25. Well, how did I know? That 2 up top tells me I'm going to multiply 2 times. And that's the key. Even this example of 6 to the 5th, I don't know what it is off the top of my head, but I can go ahead and write it out. At that point, I could slowly multiply piece by piece or use a calculator to help me out. But again, the key is, how did I know 5? I used 5 6s. Okay, what we're going to look at now is a few special cases. They're just examples that, they follow the normal exponent rules, but they're a little bit odd, and so it's helpful to go ahead and think about those more often. The first is if you have a fraction raised to an exponent. Always, 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 when you have a fraction raised to an exponent, write it out. Meaning 1/3 times 1/3 times 1/3. Too many people think it's 3 times 1 and 3 times 3. That is not correct. Now all we have to do is go ahead and multiply straight across. 1 times 1 times 1 and 3 times 3 times 3. In this case, I get 1 times 1 times 1 and 3 times 3 times 3 is 27. The second example is something raised to a negative exponent. A lot of people are scared of negative exponents. The way I look at it is, this thing here right now is basically over 1. Every number is. All you do with the negative exponent is bring that whole thing, base and all, down here and make it a positive exponent. And that's, if you look at it, exactly what we've done. Now from there, all I have to do is take 2 times 2 times 2, which is 8, and I'm all set. The last special example that we're going to look at is something raised to the 0 power. Off the top of your head, most of you are going to think it is 0. Very common mistake. I want you to try to remember that it's 1, and I'm going to show you a way to kind of help you remember that. Okay, so again, y is equal to 1. Let's take a look at a piece of paper. Now, one thing I discovered a little while back is that if you fold a paper in half, it's very similar to something like 2 to the power. So for example, the 2 is the number of times I fold it. So since I fold it in half, okay, that means that it's a 2. Let's try that again. Okay, so first of all, let's go ahead and take a look at this piece of paper. What I learned a little while back is if you fold paper in half, as in cutting it into 2s, as you can see here on this example, that it follows the pattern of 2 to the 1st, 2 to the 2nd, 2 to the 3rd. So the first thing I'm going to do is I'm going to take that 1, and that's how many times I'm going to fold the paper. So first thing I do is I go ahead and fold it 1 time, right in half. As you can see, now I have one piece stacked on top of the other piece, which gives me 2 pieces thick, and that's the same answer as 2 to the 1st power. What if I extend that? What if I were to make it 2 to the 2nd power? Well, this time I have to fold it in half, and then I have to fold it in half again. And that ends up looking something like this. Now from there, just counting, as you can see, I end up with 4 pieces of paper thick, which means 2 to the 2nd power is 4. I'm going to extend this one more time to 2 to the 3rd power, which those of you that have been around exponents for a while notice that's 2 times 2 times 2, which is of course 8. If I use my paper rule though, that's me folding it in half, folding it in half, folding it in half again. And what would end up as the result is 8 pieces of paper thick, which of course is 2 to the third power. So, why is this important? Well, now let's look at 2 to the 0 power. Remember, 2 represents cutting it into 2 equal pieces. 0 now represents the number of times I fold it. Well, what happens if I never fold this piece of paper? How thick is it? As you probably imagine, it's still 1 piece of paper thick. And that is a way to remember why 2 to the 0 power, anything to the 0 power, is 1. Moving along, we're going to jump right into the exponent rules, the basic exponent rules you should remember from previous years. We're going to start off each time with what we call a generic equation. MNA, no numbers involved. The purpose behind that is to make a rule that works every time. But in order to do that, we might want to look at what's really going on. So I'm going to go ahead and start off by writing out with this example of a to the fourth and a to the third. You'll notice as well on here that we pointed out that they both have the same base. That's very important if you're going to do this. Now what I chose to do is I chose to write it out. So if I want to take a to the fourth, that's a times a times a times a. I still got my multiplication sign in the middle, and I'm going to go ahead and write out a to the third as well. Now what I want to look at is how can I take that and write it as one simple exponent? Well, the rule of thumb is as many things are multiplied by themselves, that's the exponent and its power. So very simply put, if you look here, I've got 4 from one and 3 from the other, which gives me a to the 7th. Applying that to a general rule, it's saying no matter what m is and no matter what n is, you add them together to multiply exponents. So really quickly, what I want you guys to do is I want you to pause the video and I want you to try each of these. As soon as you're finished, hit play and we'll check your answers. Okay, so moving along, 2 plus 3 is 5, 2 plus 5 is 7, and 4 plus 2 is 6. Notice I did not change my bases on any of the 3. This remained a 7, this remained a 2, this remained an x. That's a very important concept as you go forward in algebra. Okay, next up we're going to look at the division rule. Very similar. If you think about multiplication, multiplication turned into addition, so division logically would turn into subtraction, and in fact it does. So first thing we're going to do is we're going to look at a to the 6th divided by a to the 2nd. I'm going to use my rule of writing it out. Even though at this point we do know that there is probably a shortcut, we want to make sure we can visually see it. So on top I have 6 a's, on the bottom I have 2 a's, and I'm going to follow my normal rules of canceling out each one. I'm going to start off there, then move to there, and what I'm left with is a to the 4th. Okay, now if I want to take that and I want to apply it to a shortcut, what I have to remember is that 6 divided by 2 is not my answer. When we're talking about exponents, we need to use addition or subtraction. In this case, it would be subtraction. 6 minus 2 is 4. Then applying that to a general term, it means no matter what I have for m, no matter what I have for n, the rules apply. Okay, next up, we're going to go ahead and have you pause the video and try a few on your own. So go ahead and hit pause. When you're done, hit play and we'll check if you're right. Okay, so we're going to be using the basic subtraction methods. As you can see, each of these has a larger number on the left side than the right side. That's just for purposes of making this simple. And I'm going to go ahead and show you an example where a larger number is on the right side in a second. So here, 6 minus 3, 7 minus 5, and 9 minus 8. Okay, now what I want you to look at is this is a specific example with the number on the right side being larger. As you know, the best bet is to write it out if you're not 100% sure. At that point now you'll see there is far more on the bottom than there is on top. So I'm going to go ahead and I'm going to cross off the common terms. And instead of trying to take all of those and move them on top, I'm going to recall that when I do cross things off like that, really what I'm doing is I'm creating a big 1. 4 divided by 4 equals 1. So therefore, I'd have to have a 1 there. It's very important as we go forward. So now what happens here is if I try to apply my rule, I'm going to get 2 minus 7, which is negative 5. And then hopefully from there, the person, by moving the negative 5 to the bottom. I'm going to go ahead and leave it like that, but you could go ahead and figure out what 4 times 4 times 4 times 4 times 4 is. But I think the idea is what's really important here. So again, we're going to move on. We're going to move on to the last rule we're going to talk about today, which is an exponent raised to another exponent. Most people, I think, realize that this ends up being multiplication, but let's take a quick look at why. Well, first of all, that's like saying I've got a to the 4th multiplied by itself 3 times, which is this. So from here now, I'm not going to use the multiplication rule. I'm going to go ahead and use the rule that says when I multiply exponents, as long as the bases are the same, I can add the exponents. So in this case, 4 plus 4 plus 4 is 12. So go ahead now, try these problems on your own. Pause the video. When you're finished, go ahead and hit play and we'll check how you did. All right. So in this case, remember the shortcut rule is to go ahead and take this and multiply 6 times 3. Another good alternative, like I said before, t to the 6 times t to the 6 times t to the 6, and you'll get your answer that way as well. In this case, 6 times 3 is 18, 5 times 7 is 35, and 8 times 2 is 16. All right, so the next thing we're going to talk about is what if there is a rule for addition and subtraction. We looked at what happens when you multiply exponents, what happens when you subtract exponents, but we have not looked at what happens when you add or subtract them. So here's an example. What do you think might a rule be when I add those two together? Okay, well, the reality is there is no rule. And we're going to take a look at why that is in a second. Again, going to concrete examples so you can really visualize it. Let's say I wanted to take 2 to the 2nd plus 2 to the 3rd. Well, I'm going to go ahead and go out on a limb and say some of you are going to think I'm going to add those together, which is going to be 2 to the 5th. However, 2 to the 2nd is 4, 2 to the 3rd is 8, so when you add those together, you get a grand total of 12. So instead of it being 2 to the 2nd plus 2 to the 3rd, let's look at what 2 to the 5th actually is. In fact, it's 32. So not only is the number far too large, if I go ahead and apply that and say, well, what if I multiply them? 2 to the 6 is going to be even larger. In fact, it's going to be 64. So neither of those options is a viable one, is one that actually works. In fact, like I said before, there is no rule that actually works. When you have something like a to the 2nd plus a to the 5th, there's nothing you can do. Your final answer is what you started with. Okay, so what I want you guys to do now is I want you to go ahead and pause the video. Down below, you will see either a quiz or you'll also see a quick check-in form. It's very important that you use the check-in form as my way of making sure I give you credit for the class.